Welcome back to the deep dive. Today, we are doing something that I honestly think is maybe more valuable than just reviewing a set of results.
That's a big claim.
It is, but think about it. Usually, we take a book like the one on our desk today, and we tear apart the conclusions. We're always looking for the what.
Right. The takeaways. What are the actionable strategies? What are the tips?
Yeah.
How do I make my team faster tomorrow?
Exactly, and that's why people listen. It's why they buy the book. But today, we're hitting the pause button on the what.
Okay.
And we are pivoting entirely to the how. We're going to be looking at the machinery of truth itself. Because let's be honest, if you open up your phone right now, you check your newsfeed, check LinkedIn, what do you see?
Oh, it's just noise. Absolute noise, an avalanche of it.
It's a complete avalanche of strategies, 5 ways to optimize your workflow, 3 secrets to digital transformation, how to use AI to take over the world before lunch.
And they all promise the same things.
Always. Making our lives easier, making us happier, helping our companies, win in the market.
And the fundamental problem with that bombardment of information, is that it's so hard to tell the difference.
The difference between what?
The difference between a random action that just happens to coincide with success and an action that actually drives success. We see a successful company, we see they have beanbag chairs and, I don't know, a ping pong table.
Right.
And we think, aha, that's the secret. If I buy a ping pong table, my stock price will triple.
That is the core struggle, isn't it? It's that whole cargo cult mentality. We just mimic the surface level traits of successful people or companies without understanding any of the underlying mechanics.
Precisely. And that is a classic confusion of correlation and causation, which I think we're going to be talking about a lot today.
A whole lot.
But to really strip that away, to get to the actual signal amidst all that noise, you need rigorous research. You really do. And specifically, you need to understand the difference between a hunch and a hypothesis.
So our mission for this deep dive, then, is to decode the science behind this book. We're basing this whole discussion on a specific chapter from our source material that really just pulls back the curtain on the methodology they use.
Yeah, it's a great chapter. It's a bit of a meta discussion.
It is. We aren't just looking at the results. We are looking at how they know what they know. We're going to look at primary versus secondary research.
The nature of data itself.
And a really fascinating framework for analyzing that data called the ladder of analysis.
Which is such a useful mental model to have.
It really is. And I promise you, by the end of this, you are going to understand why eating cheese might be, well, dangerous, but not for the reasons you think.
That is a tease, for sure. But yes, the cheese example is absolutely crucial, understanding why your business dashboard might be lying to you every single day.
It's my favorite part. I can't wait to get to it. But okay, let's start at the foundation. The text makes a really big distinction right out of the gate between primary and secondary research. I feel like I remember these terms from, some college course ages ago. But let's unpack them for the real world, because I think most of us live in one bucket and just assume it's the whole world.
That's a really fair assessment. So the only difference that really matters is who collects the data.
Okay.
Let's start with secondary research, because you're right, that's what most of us are exposed to every single day.
All right, secondary research.
Secondary research is when you use data that was selected by someone else. The source material uses this great analogy of a school book report.
Oh, I remember those.
Right. Think back to when you were a kid. You have to write a report on, say, the solar system.
Yeah.
You don't build a rocket yourself, fly to Mars, and take soil samples.
I certainly didn't. I went straight to the library, pulled an encyclopedia off the shelf.
Exactly. You go to the library, you pull perfectly good books that other people already wrote, you summarize them, maybe you synthesize a few different sources, and you add your own little bit of insight. That's secondary research.
So in a business context, what does that look like?
That's your case studies, your market research reports from big analyst firms, white papers, where a company has just aggregated existing stats from, like government databases or other reports.
And there's huge value in that, right? I mean, we're not dismissing it.
Oh, absolutely not. It's fast.
Sure.
It's usually much, much less expensive because you aren't paying to actually go out and collect the data. If the information is hard to find, having someone else summarize it is a lifesaver.
Yeah, I sense a but coming.
There is a massive downside that often gets completely overlooked in the corporate world.
Which is?
You are bound by their data. You are stuck with the questions they decided to ask.
Ah.
So if you want to know something super specific about your industry, say, you want to know, does using this specific type of cloud architecture impact developer burnout? But the existing report didn't ask that exact question, you're just out of luck.
You can't interrogate the data any further.
You can't. It is what it is. You can't zoom in.
You're basically painting within someone else's lines.
That's a perfect way to put it. Now, contrast that with primary research. This is when the research team goes out and collects completely new data.
And the source material gives the example of the United States Census,
which is the gold standard.
Yeah.
Every 10 years, the government doesn't just look at old records or guess based on tax returns. They go out and they count. They collect new data to get a fresh picture of demographics and population.
So the pros and cons here seem pretty obvious then. The pro is you get to play God. You get to ask whatever questions you want.
Right. You have all the power and control. If you have a specific hypothesis in mind, like, does using this very specific technology practice actually improve profitability? And nobody's ever asked that before. Primary research lets you go find out.
You're not just reading the map, you're drawing it.
Exactly. You are reporting on information that is simply not known to the world yet. It's discovery.
But the con has to be the price tag and the time.
Cost and time. Immense amounts of both. It is incredibly resource-intensive to design a good study, to find participants, collect the data, clean the data, and then analyze it. It's a huge undertaking.
Which is why so few organizations actually do it well.
Exactly. But the book we are discussing and the State of DevOps reports that are sort of its foundation are all based on this kind of rigorous, large-scale primary research.
So to be clear, they didn't just read a bunch of other people's blog posts about DevOps and summarize them.
Not at all.
They went out and they asked the industry brand new questions year after year.
Correct. And that distinction is absolutely vital because it means the insights you get aren't just, recycled wisdom. They are empirical observations of what is actually happening on the ground right now.
Okay, so that's a huge piece of the puzzle. Once you decide to go the primary route and you're collecting your own data, you immediately run into the next big divide. And I think of this as the battle between the poets and the quants.
Qualitative versus quantitative.
It's a classic tension, isn't it?
It is. And honestly, a lot of people really misunderstand what these terms actually mean in practice. There is this tendency to dismiss one or the other, but they really serve completely different functions in the, as you said, the machinery of truth.
So the text defines qualitative research pretty simply. It's data that is not in numerical form.
Right. Think words, not numbers. Qualitative data is things like long-form interviews, blog posts, Twitter threads, maybe detailed system log data that's just text, or ethnographic observations.
What's that last one? Ethnographic observations.
That's where a researcher literally just sits with a team, watches them work for days or weeks, and just takes detailed notes. It's about observing behavior in its natural context.
Okay, so it really feels like the story side of the data, the narrative.
It is. And it's incredibly valuable for that reason. It's very, very descriptive. If you are studying a complex system or a completely new phenomenon, qualitative research allows for emergent behavior to be discovered.
Emergent behavior.
You might find things you didn't even know to ask about. Someone might mention some tool or some frustration in an interview that wasn't on your radar at all, and that becomes a new thread to pull on.
But the analysis seems like a total nightmare. I mean, how do you put a really interesting interview into a spreadsheet and analyze it at scale?
You can't, really.
Yeah.
Not without converting it.
Yeah.
And that's the big challenge. Analyzing qualitative data is difficult, and it's very costly. You usually have to codify it.
Which means?
It basically means you or your team have to go through hundreds of pages of transcripts and start tagging themes, turning those words into numbers so you can measure how often something comes up. It's super subjective and very, very time-consuming.
Okay, that makes sense. Which brings us to the other side of the coin, quantitative research.
The realm of numbers. This is data that either includes numbers naturally, like system logs that have response time, stock prices, CPU usage, or data that has been intentionally structured into numbers.
Now, here is where the source material points out a huge misconception. And I think a lot of people, myself included, assume that if you're doing a survey, that's qualitative.
Oh, yeah, that's a very common mistake.
Because you're asking people what they think. You're asking for their opinion, their feelings.
People think survey equals feelings and feelings equals qualitative. But it depends entirely on how you ask the question. If I give you a survey and I ask, tell me in your own words how you feel about your deployment process, and I give you a big blank text box to type in.
That's qualitative. It's unstructured text.
Exactly. But if I use a specific tool, a specific instrument, to capture that feeling as a number, it becomes quantitative. And the tool the researchers used here is called the Likert type scale.
Ah, the Likert scale. We have all taken these a million times. On a scale of 1 to 7, how much do you agree with the following statement?
That's the one. It creates a consistent, repeatable measurement approach. For example, strongly disagree is a 1, neutral is a 4, strongly agree is a 7.
It feels a little arbitrary, but it's not, is it?
It's not arbitrary at all. It's a very deliberate way to force a subjective experience, a feeling, into an objective numerical framework.
And why is that conversion so important? Why do we have to turn the feeling "I strongly agree" into the number 7?
Because once it is a number, you can perform powerful statistical analysis on it. You can calculate averages across thousands of people. You can calculate standard deviations. You can run correlations.
Right.
You can treat a concept like organizational culture or psychological safety with the same mathematical rigor that you treat server uptime. If you leave it as text, you're just guessing at themes. If you make it a number, you can actually crunch it and test things.
So the research in this book, just to be super clear, is quantitative precisely because they used this Likert-type survey instrument to structure all that human feedback into data.
Yes. They took these fuzzy, complex concepts like how good is your architecture or how safe do you feel to fail, and they turned them into hard data points that could be subjected to rigorous scientific testing.
Okay, so we've established they did primary research, and it's quantitative data. Now what do we do with it? This is where the source material introduces a framework from a Dr. Jeffrey Leake at Johns Hopkins.
Yes, from the Bloomberg School of Public Health. It's called the ladder of analysis.
And it's basically a hierarchy, right? It's a way of ordering how much you can really learn from your data, and it gets more complex as you go up.
Exactly. It orders the types of analysis by increasing complexity, which also means increasing cost, time, and the knowledge required to do it right. It's a great framework because it stops you from overclaiming what your data actually proves.
It forces you to be honest.
It really does. It forces you to be honest about the limitations of your analysis.
Okay, so let's start at the bottom of the ladder. Rung number 1 is level 1, descriptive analysis.
This is the foundation of everything. The goal here is incredibly simple. Summarize and report. Just describe what you see in the data.
So this is like the census report again?
Perfectly. There are 330 million people in this country. 51% are female. The median age is 38. You aren't explaining why they're there. You aren't predicting where they will go next. You are just holding up a mirror to the data set.
The text mentions that this is often the very first step for any research team, just to get a feel for what they've collected.
Right. You have to understand the basic shape of your data.
What?
But there's a massive, massive trap here that we absolutely need to discuss.
Okay.
And that is the difference between the population and the sample.
Oh, this is good. This is where companies get in so much trouble constantly. Let's break this down.
All right, so the population is the entire group of people or things that you are interested in studying. If you are studying software engineers, the population is every single software engineer on planet Earth.
Which is completely unmanageable. You can't just send a DM to everyone on GitHub.
Totally inaccessible. You cannot ask every engineer on Earth a question. So what you do is you take a sample.
A smaller piece.
A carefully defined, selected portion of that population. And you perform your analysis on that sample.
Okay, that makes sense.
But, and this is the but that ruins so many business strategies and marketing claims, your conclusions are only true for the whole population if your sampling method was actually good.
Give me an example of a bad sample, a common one.
Okay, well, imagine you want to know if a new software tool is popular with developers. So you decide to survey the people attending that tool's annual user conference.
Well, of course they're going to love it. They paid money and traveled to be there. They're the true believers.
Exactly. That is a profoundly biased sample. If you take that descriptive analysis, 99% of users at our conference love this tool, and then you try to apply that to the general population of all engineers, you are lying. You're being deceptive.
You're presenting a very specific biased subset as if it's the universal truth.
Precisely.
So descriptive analysis is great for those big state-of-the-industry reports we see from places like Forrester or IDC, but it has these built-in limits. It tells you what is happening inside your sample.
But not necessarily why it's happening, or if it's happening everywhere else in the world. And that brings us up to level 2 on the ladder. Exploratory analysis.
The fun stage.
It really is the fun stage. This is where you put the data into charts and visualizations. You start looking for patterns, for relationships. You start to act like a detective with a big wall of clues.
The source material calls this the stage for divergent thinkers. This is where you generate new ideas. You're looking at a scatter plot and you go, wait a minute, That's weird.
Yes, you might notice, hey, every time variable A goes up, variable D seems to go up too. Or maybe it goes down. That's
Yeah.
a correlation. You are finding potential relationships that you didn't even know existed before you looked.
But we have to stop right here because we are approaching the danger zone.
We are standing at the edge of a cliff. This is where most bad business advice is born.
Because level 2 exploratory analysis identifies correlations. But as we have all been told 1,000 times, and as we all seem to forget 1,000 times,
Correlation does not imply causation.
it's the most repeated phrase in all of statistics, and yet it is the one we ignore the most often in business, isn't it?
Absolutely, because we are desperate for causation. We want to know if I do X, I will get Y. Exploratory analysis cannot tell you that. It can only tell you X and Y seem to happen around the same time.
The text has the absolute perfect example for this. It references a website called Spurious Correlations by Tyler Viggen. Have you seen this site?
I have. It is absolutely brilliant and hilarious, but it is also a terrifying lesson in data literacy.
So for you listening, I want you to imagine a chart with 2 lines on it. One line going up over time is per capita cheese consumption.
Okay.
The other line, also going up over time in almost perfect sync, is the number of people who died by becoming tangled in their bed sheets.
And if you look at the data for a decade between 2000 and 2009, these 2 lines move in almost perfect lockstep. It's uncanny.
The statistical correlation is 94.71%. That is a staggeringly high number. If you saw that correlation in a business report, say, between marketing spend and revenue, you would bet your entire career on it.
You would. You'd stand up at a board meeting and say, the data is irrefutable. Look at the R value.
But let's just apply a tiny bit of common sense here. Does eating more cheese cause you to get tangled up and die in your sheets?
I mean, unless it's a very, very specific type of heavy, nightmare-inducing cheese, probably not.
No. Okay, what about the other way? Does getting tangled in your sheets somehow make you crave cheese?
Maybe some sort of post-traumatic comfort eating. No, it's obviously absurd.
It's completely absurd. But the text makes a really serious point here. When we go fishing in the data, which is what exploratory analysis is, our brains are wired to fill in the gaps. We will invent a story to make the random pattern make sense.
That is the fundamental danger. We are narrative creatures. If I show you a chart with a correlation between, say, server outages and coffee consumption in the office, your brain immediately tries to link them.
Right. Maybe the sysadmins are too jittery from the coffee and they're making mistakes.
Or maybe they spill the coffee on the servers. Your brain creates a causal story, even if it's a total random coincidence. Just like the cheese.
Just like the cheese.
So if you stay at the exploratory level, if you stop at level 2, you are just finding things that happen to move together. It might be a total fluke. And if you make a major business decision based on a spurious correlation, you are essentially betting the company on a roll of the dice.
You are seeing a pattern in the clouds and you're calling it a business strategy.
Perfectly said.
So how do we move past the cheese? How do we get to something we can actually trust and build a strategy on? Because we can't just stop at, well, everything might be a coincidence. We need to know what actually works.
To do that, you have to climb to the next rung on the ladder. You have to get to level 3, inferential analysis, or sometimes called inferential predictive analysis.
This is what the text calls the gold standard for most business and technology research.
It is. And the key distinction here, the thing that separates it from the fishing expedition to level 2, is the methodology. In exploratory analysis, you look at the data first and see what you can find. You're fishing. In inferential analysis, you are not allowed to fish.
You have to call your shot ahead of time.
Exactly. You must state a hypothesis, which is based on a well-developed theory, before you are allowed to look at the data.
This is the scientific method we all learned in middle school.
It is. Step 1, state your hypothesis. Step 2, design your research. Step 3, collect your data. Step 4, test your hypothesis. You don't look for random patterns. You test a specific, pre-stated theory.
So instead of just looking at all the data and finding the cheese and bed sheets connection, you'd have to say up front, I believe, based on some theory of dairy-induced nightmares, that cheese consumption leads to bedsheet entanglement.
Correct. And this process protects you from the cheese trap, because no rational person would ever hypothesize that in the first place. You only found that ridiculous pattern because you were looking for any pattern. By requiring a theory-based hypothesis first, you filter out almost all of the random noise.
Now, the text does mention that some people argue this can create confirmation bias, that if you start with a theory you believe in, you'll just go looking for proof that you're right.
And that is a valid criticism to be aware of.
Yeah.
But the text argues, and I agree, that this is simply how science is done. You don't just confirm it. You're testing it against the null hypothesis.
What does that mean, the null hypothesis?
You basically start by assuming the opposite. You say, let's assume there is no relationship between these things. Does the data I collected make that assumption look ridiculous? If the evidence strongly contradicts the no relationship idea, then you gain confidence in your original hypothesis.
So you're trying to disprove the negative.
In a way, yes. And if the data contradicts your original hypothesis, a good scientist has to accept that and say, my theory was wrong. But the more evidence you find that supports the hypothesis across different studies and different samples, the more confidence you gain that you've found something real.
And this level 3 analysis is what the book's authors did. They used it to show that certain technical practices like continuous delivery or loosely coupled architecture actually drive organizational performance.
Right. They didn't just find a correlation. They started with a theory about how software delivery works.
Yeah.
And they rigorously tested it.
They used some fancy-sounding statistical tools. The text mentions multiple linear regression and partial least squares regression.
Yeah, those can sound intimidating.
Let's touch on regression for just a second. It's basically a way of isolating variables, isn't it? It's like a control panel.
That's a great way to think about it. Regression is a way of saying, okay, we know that big companies are different from small companies, so let's mathematically control for company size. We know different industries have different pressures. Let's control for industry.
So you're stripping away the other explanations.
Exactly. You're asking, if we strip all that other noise away, does this specific practice we're interested in still have a measurable effect on the outcome? Regression allows you to answer that. It lets you see the signal, even when there are a lot of other things happening at the same time.
Okay, so level 3 inferential is where the real, actionable truth lives for most business contexts. But the latter does go higher, doesn't it? Even if we don't see it as much in this kind of research.
It does, yes. And it's good to know they exist for context. Briefly, there's level 4, predictive analysis. This is all about forecasting, trying to predict future events based on past data.
Like trying to predict next quarter's revenue based on the last 5 years.
Exactly. Which, as anyone in business knows, is notoriously difficult. The further out you try to look, the fuzzier and less reliable the prediction gets.
And after that?
Then you get to level 5, which is causal analysis.
Wait a minute. I thought level 3 was about finding causes. You said it drives performance.
That's a subtle but really important distinction. Level 3 is inferential. It infers a relationship. The evidence is so strong that we can be very confident in saying it's a driver. But level 5, true causal analysis, is the absolute undisputed gold standard for proving A causes B without a single shadow of a doubt.
And how do you do that?
To do it properly, you usually need a randomized control trial. The classic example is a drug trial. You give half the people the real drug, half the people a sugar pill, and see what happens. In tech, we might call it an A-B test.
Which is really hard to do with an entire company.
It's usually impossible. Think about what it would take to run a true causal experiment on, say, the benefits of DevOps. You would need to find two absolutely identical companies. Same market, same number of employees, same product, same starting revenue. Then you'd have to force one of them to adopt DevOps and force the other one to stick with waterfall.
And you just sit back and see which one goes bankrupt first.
Exactly. No company is going to agree to sacrifice their profits just to be in your control group. You just can't ethically or financially do that at an organizational level. So true level 5 causal analysis is extremely rare in business research. We have to rely on the next best thing, which is very rigorous level 3 inferential analysis.
And there's a level 6. What's at the very top of the ladder?
Level 6 is mechanistic. This is physics. This is engineering. This is knowing the exact mathematical equation where if I push this variable by exactly 10%, I know for a fact the result will change by exactly 2.5%.
Like calculating the trajectory of a rocket.
Exactly. We almost never see this in complex human systems like an organization. People aren't billiard balls. You can't predict their behavior with perfect mechanistic accuracy.
Okay, so to recap the ladder, the book's research operates mostly at level 3 inferential. They have a theory based on what they see in the industry, and they use statistical methods to test it rigorously. But there is one more type of analysis that the source material mentions that doesn't fit neatly on that ladder. It's what I think of as the sorting hat of data analysis.
Classification analysis, or as it's more commonly known, clustering.
And this is how they came up with the now famous high, medium, and low performers groups that everyone in tech talks about.
It is, yes. The goal of classification, or clustering, is to find significant, naturally occurring groups within your data. You aren't necessarily predicting an outcome like in a regression. You are just trying to see if your data points naturally clump together into distinct tribes.
So how did they do it? Did they just look at all the survey responses and decide, okay, the top 20% are the high performers and the bottom 20% are the low performers?
No, and that's the real beauty of the method. They didn't predefine the groups at all. They let the data itself define the groups.
How does that work?
They took 4 key variables that they had identified as measures of technology performance. Deployment frequency.
How often you push code?
Lead time for changes.
How long from a developer's commit to it being live?
Mean time to repair, or MTTR.
How fast you can fix things when they break?
And finally, change fail rate. So what percentage of your changes cause an outage? They fed the data for these 4 variables from thousands of teams into a clustering algorithm and essentially asked the computer, are there distinct types of teams in here based on these metrics?
And the computer said yes.
The computer found very clear, statistically significant clusters.
Yeah.
And what was so fascinating, and this is one of the key insights from the entire body of work, is that the high performers were good at everything.
Right. I remembered this part. There was this long-standing belief in the industry that you had to trade speed for stability, the whole move fast and break things mantra.
Exactly. The old wisdom was, if you want to go fast and deploy all the time, you're naturally going to have more errors and more downtime. If you want to be super stable, you have to go slow and be cautious. It was seen as a zero-sum game.
But the cluster analysis showed that's not true.
It completely debunked the myth.
The analysis showed that the high-performing group had high deployment speed and high stability. They were fast and reliable. And the low-performing group was the opposite. They were slow and they were unstable.
That is a total mic drop moment provided by the data itself. It wasn't someone's opinion or a feel-good story. The data showed that the trade-off is a false choice, at least for the highest performers.
It was a groundbreaking finding, and it came directly from this classification analysis method.
The text gets a little bit into the weeds on the specific technique. It says they used hierarchical clustering. Why does that detail matter? For the listeners who are really into this stuff, why hierarchical and not something else, like k-means?
That's a great question. So the most common clustering method you hear about is probably k-means clustering. But k-means has one major requirement. The researcher has to tell the computer how many groups to look for ahead of time. You have to say, find me 3 groups, or find me 5 groups.
So you're introducing your own bias back into the process again. A little bit, yes. You're making an assumption. The reason they chose hierarchical clustering is that it doesn't require that. You just let the algorithm run, and it determines the optimal number of groups based on the structure of the data itself. It might find 2, it might find 4, it might find 10.
So they didn't force the high, medium, low structure onto the data. It just emerged naturally from the algorithm.
Precisely. That's the first reason.
Yeah.
It's a more pure way of letting the natural structure of the data reveal itself.
And what's the second reason?
The second reason is that it allows you to investigate parent-child relationships between the clusters. It builds a kind of family tree, which makes it much easier to interpret how the different groups relate to each other. It just gives you a richer, more nuanced picture of the landscape.
So, okay, let's bring this all back together. We've gone from defining the different types of research to climbing this whole ladder of analysis.
We have. And hopefully it's clear now that the research behind this book isn't just a collection of anecdotes or opinions. It is primary, quantitative, inferential research supplemented with classification.
Which means, in plain English,
it means they went out and asked new questions that hadn't been answered before. They measured the answers with numbers using valid, reliable instruments like surveys.
Yeah.
And they tested specific theory-driven hypotheses to see what practices actually drive performance, rather than just going on a fishing expedition looking for nice-looking patterns.
In other words, they avoided the cheese.
They studiously avoided the cheese. They built a machine designed to find the truth, rather than just taking a blurry snapshot of all the noise.
So, for you listening right now, the big takeaway here is that the next time someone hands you a report at work, or you see one of those flashy headlines on social media promising that, I don't know, using emojis and subject lines increases revenue by 500%, just pause for a second.
Take a breath and ask yourself some questions about what you're seeing. Ask yourself, is this descriptive? Is it just telling me what happened in one small, possibly biased sample?
Is it exploratory? Is this just a correlation they found that might be no different from cheese and bed sheets?
Or is it inferential? Did they actually have a theory? Did they state a hypothesis beforehand and test it rigorously against the data?
Because in a world that is just drowning in noise, the ability to spot the signal, the real tested inferential signal, is an absolute superpower. It stops you from wasting time and money chasing trends that probably won't work for you.
That's it. It is the difference between following a carefully drawn map and following a rumor you overheard in a coffee shop.
I love that. And I want to leave you with one final thought to mull over before we wrap up. We talked about how hard it is to do that true causal level 5 analysis in business.
Right, because you can't have a real control group.
You can't purposely tank half your company just to see what happens in a scientific experiment.
It's just not feasible.
I want you to look at your own organization right now. Think about all the strategies you're currently running. Think about all the pilot programs and new initiatives. Are those actually rigorous tests? Or are they just fishing expeditions where you're hoping to stumble upon a pattern that looks like success?
That is the really uncomfortable question, isn't it? Most companies are constantly running experiments, but they aren't running them like scientists.
How are they running them?
We're running them like gamblers. They just throw a bunch of dice against the wall and pray for a 7.
So the question to leave her with is this. In your work, in your decision-making, are you a scientist or are you a gambler? Think about that. Thanks for listening to The Deep Dive. We'll see you next time.